Okay, so we're just going to go through quickly these 4 problems here, and then we're going to move on, because what we are doing today is we are dealing with the division of radicals. So if we're not sure how to multiply radicals, that's really going to come up a couple of times today, so we need to make sure that we're okay with this. So the first one, so in your calculator in the background, right, you don't have to write this part down. So we said you have to show work, but you do not have to show what you divided by and what it came out. So if you're in your calculator, you're taking 52, dividing by 4 or 9 or 16, and all of that work can still be done in your calculator. But when you divide it by 4, that comes out to be 4 and 13. Now this is where we talked about you need to check. That 13 right there, does 13 have a radical inside of it? Like, can 13 be divided by 4 or 9 or 16? No. So we have found the biggest radical, so we can continue on and simplify this to be 2 radical 13. And again, for your algebra 2, that's plus minus, but for geometry, everything's going to be a length, so we just worry about the positives. Okay? Okay, so then we come over here to this one. If you take in your calculator and you divide 80 by 4, it comes out, right? So 80 divided by 4 is 20. But when you look at 20, does 20 have a perfect square inside of it? Can you divide 20 by 4? Yes. Yes. So that means you didn't find the biggest perfect square. So I have to go back to the drawing board and keep dividing to find a bigger perfect square. What's the bigger perfect square inside of 80? 16. 16 and 5. Okay, so we're going to use 16 and 5. This 4 is going to be on the outside. So this does become 4. The square root of 16 is 4. We'll take that 4 and multiply it times the 4 that's in the front. So your final answer should be 16 radical 5.
So you don't want to break it down any further? Because 4 could become 2.
But you only want to do that if the 4 has a radical over top of it. So once you take the square root, you don't want to square root and then square root again, because you've already done it, so that symbol goes away. And so don't do it twice. Okay? Okay? So once I take the square root of 16, it becomes 4, not the square root of 4, just regular 4. Okay? Okay, so then here, it is possible that you can take this 18 and you could break that down into 9 times 2, right? You could do that. And if you did that, that is not wrong. Or you could choose to go ahead and multiply it first and then break it down. So completely up to you how you do it. I like to multiply first, because if you break it down, then multiply, you may have to break it down again. Okay, so it's just my preference. You can do it however you want. So 15 times 18 is 270. Okay, and then we just look through 270 and see what does it have inside of it. Now, I know that this is a pretty big number, but we've got 9 goes in there and 30. And I know 30 looks like, oh, it has to be broken down because it's 3 times 10, or it's 2 times 15, or it's 5 times 6. None of those numbers are perfect squares. Okay, so 30 actually cannot be broken down. So we have the biggest perfect square right here. Final answer should be 3 radical 30 on that one. Last one, what do we do with this number on the outside? And this right here is something that you're going to see today. So both this multiplication and this multiplication, you're going to see that as a part of our notes today, but it's not the main part. So the assumption is after this, we're good to go with that part. Okay? So when you have multiplication, we're going to take the 2 numbers that are not under the radical and multiply those 2 numbers together first. So 3 times 8, that's 24. And then I'll go ahead and multiply 7 times 14. So 7 times 14 is 98. Okay? And then you can take your calculator and start dividing, right? What number do you think you should try? You could try 4 right away. You could try 9. You could try 16. But based on the 2 numbers that you multiplied, You multiplied a 7 times a 14. What number do you think might be in 98? Yeah, there's a 7 here. There's a 7 here. So 7 times 7 is 49. So 49 is probably inside of that 98. And you could try all of them. You could try 98 divided by 4, 98 divided by 9, divided by 16, divided by 36. But the perfect square in there is going to be 49. So we have 24 in the front there. Don't forget that guy. We have a 49. And we have a 2. So sometimes if you're like, oh, what should I even try? I don't want to go through all of them, right? Because sometimes it's a lot to go through all of the different perfect squares. You can kind of look at what you multiplied to get that number and then try to find something that is in there twice. So 7 was in the first one, 7 was in the last one, so 49 is definitely going to be in your answer. So the square root of 49 is 7. This is going to be a big one. We got 7 here. We'll multiply that times the 24. That's 168. Thank you. 68, and then root 2. Okay. So that was just a warm-up. That was just a practice because it's been 4 days since you've been here. So, all right, let's get right to it. So get your packets, and we're going to turn to the page in your packet that looks like so. Slide over. Yes. Can I do it at the end, though? Yeah. Yes, I will. That's a great question. Number 10 on the homework is brilliant because it's actually going to lead into our tomorrow work. That's why it's there, because it's going to lead into what we're doing tomorrow. This guy right here, though, we have to talk about what happens when I divide by a radical, okay? If you take 10 and you divide it by 2, right? So I have 10 slices of pizza, and 2 people are going to share it, right? So how many pieces does each person get? They each get 5, right? Okay. Can you divide by 0? Why not? Well, how do you split up 10 pieces of pizza between 0 people? I have no one to give it to, right? So there's nobody to give the pizza to. We all know that that's a rule, that you can't divide by 0. The reason you can't divide by 0 is because you can't divide out 10 pieces of pizza if there's no one to give it to, okay? How do you divide by a number that never ends? Like if you wanted to divide 5 by 2.5, right? That ends. I can type that into a calculator, right? The square root of 3 is a number that never actually has an ending number. So in order to divide by it, you'd have to eventually at some point round. Well, then that's not actually dividing in math. So the issue is, if you're dividing by a radical, I don't know what number to actually type in my calculator because anything you type that in, it's going to round it to divide. So when we're looking at exact answers, okay, so you're going to see this on your test and on your quiz. It's going to ask for the exact answer. And anytime you put something in your calculator is rounding. All right, so this radical cannot be in the bottom because I don't know how to divide by a number that never ends, just like you can't divide by 0. So the reason we need to do this is because we cannot divide by radicals, because radicals never stop. Okay? So how am I going to give an answer that doesn't divide by a radical? Okay, so how do I get rid of this on the bottom, because my answer's not done? So this rationalizing the denominator just means I need to make the denominator a whole number. So in order to make this number a whole number, I'm going to multiply it times itself. Well, how's that going to help? What's radical 3 times radical 3? Radical 9. What's the square root of 9?
3.
Hey, that's a whole number. Right? Okay, so that's why we're doing it times itself. But if you multiply something on the bottom, you can't leave out the top, right? So you also have to make sure you do it on the top. So really, am I changing the value of the number? No, because I'm actually just multiplying by 1. What's radical 3 over radical 3 is just 1. So I'm not actually changing the value of the number. I'm just changing what it looks like. So on the top, this is pretty straightforward. On the top, I have 5 radical 3. That's it. 5 radical 3. That's what I have on the top. And then you just told me this a second ago. What's radical 3 times radical 3? That's radical 9. But what's the square root of 9? 3. So what I have is I have 5 radical 3 over 3. Now I know I'm dividing it up by 3 people. So you have to have a rational number, and square roots are irrational. You have to have a rational number on the bottom of any fraction. Okay? Okay, let's try again. Let's go down to this one here. So the next one below it says 12 over radical 3. So what are you going to multiply by? Radical 3 over radical 3. Top part's easy. 12 times radical 3 is just, don't overthink it, 12 radical 3. What's radical 3 times radical 3? It's radical 9. What's the square root of 9? 3. This is going to happen every single time. When I multiply any radical times itself, what is it going to end up being? Just that number. So if I took radical 7 times radical 7, I would end up with the number 7. Okay? So as we're going, if you don't want to write that middle step, okay, so if I don't want to write radical 9, oh yeah, that's going to be 3. Anytime you take a radical times itself, it's just going to give you that number. So radical 2 times radical 2 will just be a 2. Okay? The last thing that we need to talk about is if you can reduce, you should reduce. Okay, so up here at the top, we had a 5 divided by 3. Can 5 and 3 be reduced? No. Trick question. Can 3 reduce with 3? No. It's a trick question because I didn't actually read the number. It's not 3, it's radical 3. So can radical 3 be divided by regular 3? No. So those can't be reduced. But here, can 12 be divided by 3? Yeah. So if you can reduce it, you should. So 12 divided by 3 is 4.
Then would we
Radical 3.
solve that, or is that the answer?
That's it. That's it. Right? And now the other thing is I just took something that was division, okay, and was a fraction, and now it's no longer a fraction, so it's a lot nicer to look at as well. Okay? So I'll give you a few minutes. You've got 1, 2, 3, 4 right there, right, that you can work on and see how that goes. So I'll give you a few minutes to work on those first 4. Again, remember, you have to show work to get credit. So I know that you might be able to do this, but just remember on your test and your quiz, I can't give you credit for it if you're not showing any interim work. So just FYI. Okay, let's jump down to the next little group here. So in the next group, the only part that's different is it's got a number in the front here at the bottom, right? So what do I multiply by? You technically could multiply top and bottom by 4 radical 3. You could. But your numbers are just going to get big. So all you need to do, the only part that it's necessary, is to get rid of the radical. So the only thing you have to multiply by is the radical 3. Could you, on a test or a quiz, if you accidentally multiplied by 4 radical 3, would that be wrong? No. It's just a lot bigger numbers. Okay, a lot bigger things to work with. So we really only have to multiply by the radical 3. So what would that give us? Across the top, 6 times radical 3, that's still just 6 radical 3. Now across the bottom, what would you have? There's a 4 on the outside. 4 radical 9. What if I didn't want to write radical 9? What could I write? 3. 3. Okay, so you could write also 6 radical 3 over 43? 12, because it's 4 times 3. Good, so we would multiply those two numbers. So if there's a 12 on the bottom, wait. Should I reduce? Yes. So I should reduce this 6 and the 12 to be 1 over 2. Okay, so you can still reduce if the two numbers on the outside can and should be reduced. Good.
So you don't want to reduce before you do it at all, though?
You could. You could.
You could get 3 over 2 radical 3.
Yes, because that's what I'm going to... 3 radical 2 over 3?
Or 3 over 2 radical 3.
Yes, and then go. Yeah, no, sorry. Just my brain took a second to process that. Yeah. So you would get it eventually. So the difference is, the reason I don't do that is because then you reduce, then you multiply, then you reduce again. See, I just take out the first step and just do it all at the end. But if you want to work with smaller numbers, there's nothing wrong with that. So you got 1 at the top. And you don't have to write that 1 if you don't want. Okay, now it was nice. On 5 and 6, there's no reducing that you have to worry about. You just have to worry about that multiplication piece. Okay, so this again is another preference question. Okay, so it kind of goes to what we were just talking about with that reducing and then the multiplying and the reducing. So you get to choose here. You could, if you wanted to, right now, multiply top and bottom by radical 20. You could, right now, go. Radical 20 over radical 20. But, do you see that radical 20 needs to be simplified? Yeah, so you could simplify first and then multiply. So it's kind of up to you when, in the order of things you want to do that, if you want to do that at the end, or if you want to do it right away at the beginning. Okay, so this time, for those who like to reduce and use smaller numbers, I'll go ahead and deal with my radical part first. So this radical 20, is 4 times 5, which means on the bottom I have 2 radical 5. So again, right here, can I reduce? Yeah. Yeah, I can go ahead and reduce this 4 and this 2. I can reduce that. So if I want to reduce, now I have 2 over 1, so 2, but my radical 5 is still in the bottom. Be super careful about that. That radical 5 is still in the bottom. Sometimes when you reduce, right here, you take the 2 and the 4 and you divide them, and oh, radical 5 just magically becomes on the top. Okay, so it's still on the bottom. So now what I have, because I did all of my reducing first, the problem I'm looking at is just like problem number 1. Okay? So if you want to reduce at the beginning, then this radical piece looks a lot simpler. Again, up to you if you want to do it at the beginning or if you want to do it at the end. So I still have to do this, radical 5. So 2 radical 5 on the top. Okay, are you comfortable with this yet? What is radical 5 times radical 5? Just 5. And you can just put 5. You don't have to put radical 25. You can just put 5. Okay, anytime you take a radical times itself, it's like taking the square root of 5 squared. It's just 5. If you can reduce, you should still reduce, but the only two numbers I can reduce are the 2 and the 5. Okay, and those can't be reduced, so I move on. So same thing, I'm going to give you a few minutes. I'm going to walk around, kind of help you out. Ooh, sorry. Working on 5 through 8. Okay, 5, 6, 7, 8.
I bet you someone gets drafted and jumps in the water.
Oh, yeah.
Yeah.
Like this particular will.
Why not just have a normal draft?
Yeah, that's...
Last year's draft was just fine. But no, they want it to be in Vegas because the Raiders are moving. The draft would be on water. Yeah. Like on the Bellagio House in Vegas. No. It's just so extra for no reason.
I mean, kind of cool.
Weird.
If I got drafted number one, what do you think I'm gonna do? I'm gonna jump in.
Yeah, but Joe Burrow's not going to jump in the water.
He won't. He won't.
He won't.
I'm kidding.
He
He's
won't.
very
Other
classy.
players, yeah.
Like Trevor Lawrence,
He's not going to be drafted.
I think he's...
I hope none of you have to watch the video from today because you get to hear all of this again.
There's a video.
It's recording right now.
Hi, video.
My bad.
You just get Trevor Lawrence.
No, because he's not declaring. He's a freshman.
He's a sophomore.
Yeah.
He's a junior. He leaves next year. No, I think
No, but he's not
Saying
declaring.
rookie,
You know what you know. Okay, we're flipping over to the backside. So we're talking about dividing. So rationalizing the denominator is great, but if at all possible, you can avoid rationalizing the denominator, let's do that. Okay? So there are two different ways that you can avoid rationalizing the denominator, but sometimes you just have to do it. So we'll talk about a couple different scenarios. The first one is, if you can actually divide the numbers that you're looking at, divide them first. Okay, so for example, this first one says 40 over 5. Do you see how both of them are underneath the radical? Since they are both underneath the radical, you can actually divide them. So does 40 divide by 5? Yeah, let's divide it. So 40 divided by 5 is the square root of 8. But the numbers that you should get used to, your 8, your 20, your 12, those numbers, anytime you see them, need to be simplified. And you're going to simplify them so often that hopefully you know what it is simplified. Okay, so the square root of 8 has a 4 and a 2. So that 4 becomes 2, radical 2. So if you can divide the numbers, you should, because they are both underneath the radical, so they can be divided before you try to rationalize, okay? The second thing you want to look for is you want to look for a perfect square. If that bottom number is a perfect square, make it that rational number by just taking the square root. What's the square root of 16? 4. Now, I have not taken the square root of the top number, however. So the top number still has to stay underneath that radical. But do I need to rationalize anymore? No, I've got that whole number on the bottom, so I'm good to go. So I'm done. 30 doesn't have any sort of perfect squares. I know you really want to break it down like 6 times 10 or 5 times 6 or, 3 times 10 or 6 times 5 or 2 times 15. None of those are perfect squares. So 30 actually gets to stay radical 30. Okay, let's practice that again. Let's come down here to this one. The square root of 96 and the square root of 12. What you're going to want to do right now, right away, is you're going to multiply top and bottom by radical 12, right? Can 96 be divided by 12? Check and make sure before you just multiply by 12. Does 96 divide by 12? Yeah, what do you get? 8. Isn't that a whole lot nicer to deal with radical 8 than to deal with, I don't know what 96 times 12 is, but I'm having to work with 1,152, right? No thank you. So radical 8 is a lot easier to deal with, and then we would end up with 2 radical 2 like we did above. Okay, so if you can divide, you should. If you can't divide, then we need to fall back on that rationalizing the denominator. Okay. Okay, so one more, two more examples, and then I'm just going to give you some time to work / finish, and if we don't finish this is the homework for today. So the first one down here, the last one at the bottom, and then we'll go up to number 9. 4 radical 6 over 3. Can you reduce? Can you simplify? Can you divide? This is the thing we have to get rid of, is radical 3. You could, if you wanted to, multiply top and bottom by radical 3. But if you just stop and take a minute and you divide first, 6 divided by 3 is radical 2, and I don't have to do anything else. Okay? So that's one thing. If we can avoid rationalizing the denominator, we should. However, there are going to be times when you can't avoid it. For example, number 9. So let's go back up to number 9. Can 6 be divided by 5? No. So I'm going to have to do this radical 5 over radical 5 business. And what we did on the front side is we said 6 radical 5. But these are both radical numbers, so that's why we did on the warm-up. We have to actually multiply them. 6 times 5 is 30. And then radical 5 times radical 5 is just plain old 5. Okay, so how do I show work on this? Right here. You showed me what you did. That's enough. Okay, sometimes there's not a whole lot of work to be done. Okay. Okay, so if you don't finish this, this is homework on the back side, but we had the question of number 10. Okay, so I can do that in maybe like 2 minutes. I'll give you like 2 or 3 minutes, and then we'll do that question number 10, which is just on the page right before this one. Okay, so go ahead and work on those questions. 10 through 15. I didn't even put one on number 16.
So can you usually hear us? You in the video?
She can usually hear you.
That's great.
Oh, cover the whole thing. Yes, yes. So I should just do. Mm-hmm. Yep, it means the same thing.
So, divide them.
So you can check to see if it's a perfect square. So this one was a perfect square. So just take the square root of it and
So,
if it's not a perfect square, if it's not a perfect square, check and see if I can divide. So this one can divide. And then if it can't divide, so then this one goes 7 and it can divide. Then you have to do this.
I don't know. You,
Same thing.
how did that go?
The square root of 5 times the square root of 5 is 25, right?
that probably
What's the square root of 25?
No, it's not something like
make up. And usually open gym for about 30 minutes. For 30 minutes.
because, like, they have to make up, depending on how many people have to make up. And then,
You get your groups set.
no, tomorrow,
You're at the gym right now.
yeah. And then, after that, like, you get to touch a little bit, and then they,
Alright, so I promise Sydney's going to help remind me. We're going to go over question 10 at the beginning of class.
they talk about
Tomorrow.
boundaries.